Right now, as you read this, your brain is holding between 40 and 70 incomplete thoughts in active neural loops, exposed conversations, unresolved worries, half-formed ideas that never found their endings. In 2023, neuroscientist Jimo Borjigin at the University of Michigan recorded what happens to these loops when the brain dies. What she found was not silence, it was a surge. A final, ferocious burst of gamma-wave activity, the exact frequency associated with conscious awareness, erupting in the dying brain like a last transmission no one was meant to intercept. You have been told your whole life that death is an off switch. One moment, thoughts, the next moment, nothing. A hard stop. The way a candle goes out, the way a computer screen goes dark. Clean, final, instant. This is wrong. And the evidence proving it wrong is not coming from philosophy departments or religious traditions. It is coming from intensive care units with EEG machines still attached to dying patients. What actually happens inside your brain in its final moments is the opposite of shutting down. Your brain does not quietly accept its own death. It fights. It accelerates. It produces more organized, more coherent, more intensely structured electrical activity than it generates during normal waking life. And the specific content of that activity, the neural signature it produces, corresponds exactly to the brain regions associated with conscious experience, memory recall, and visual processing. The uncomfortable question is this: if your brain is generating its most intense conscious output at the moment of death, what is it doing with your unfinished thoughts? Where are those incomplete patterns going? And does the brain know something about its own ending that you do not? The research is still evolving on this, but what 3 separate studies from 2013 to 2023 have found challenges every assumption you hold about what death means for your mind. To understand what your brain does with unfinished thoughts, you first need to understand why unfinished thoughts exist at all, and why your brain treats them differently from every other type of mental content. In 1927, a Lithuanian psychologist named Bluma Zeigarnik noticed something peculiar while sitting in a Viennese restaurant. The waiters could remember complex orders with perfect accuracy, but only for tables that had not yet paid. The moment a bill was settled, the details vanished from their memory as if erased. Zeigarnik took this observation into the laboratory at the University of Berlin. She gave subjects a series of simple tasks, puzzles, arithmetic, bead stringing, and interrupted half of them before completion. The result? Subjects recalled the unfinished tasks 90% better than the completed ones. Your brain does this constantly. Every uncompleted thought, every unresolved emotional exchange, every problem you set down without solving. Your prefrontal cortex maintains an active neural loop for each one. These are not passive memories, they are live circuits. Neurons in your dorsolateral prefrontal cortex fire persistently, sometimes for hours, sometimes for days, maintaining the pattern of an unfinished thought in what neuroscientists call working memory reverberation. Think of each unfinished thought as a spinning plate on a stick. Your brain allocates actual metabolic energy to keep each plate spinning. A conversation with your daughter that ended abruptly. A decision about your health that you never fully resolved. A creative idea that sparked and then got interrupted. Each one has dedicated neural real estate. Each one draws glucose and oxygen from your bloodstream to stay active. Research published in 2015 from Earl Miller's laboratory at MIT demonstrated that prefrontal neurons do not simply store information passively during working memory. They fire rhythmically, in bursts of gamma oscillations between 30 and 100 cycles per second, maintaining each item through active, energy-expensive repetition. Your brain is literally rehearsing your unfinished thoughts on a loop, over and over, burning fuel to keep them alive. Now here is the question that should disturb you. What happens to those spinning plates when the stick falls? When your prefrontal cortex loses its blood supply? When the oxygen runs out and the glucose stops flowing? Do 40 active thought loops simply vanish simultaneously, like 40 candles blown out by a single breath? Borjigin's data says no, emphatically no. And the mechanism her team discovered reveals something about your dying brain that no neuroscientist expected to find. But here is the part nobody mentions. It is not just that your brain stays active during death. It is that your brain becomes more active, more organized, more coherent, as if your unfinished thoughts are being gathered together for something. In May 2023, Borjigin's team published their findings in the Proceedings of the National Academy of Sciences. They had monitored 4 comatose patients in the ICU, patients already determined to be beyond medical help, as life support was removed. All 4 were unresponsive. All 4 showed flat or near-flat EEG activity before the ventilators were withdrawn. Then their hearts stopped. And in 2 of those 4 patients, something erupted. A massive surge of gamma wave activity, oscillations between 30 and 100 Hz, exploded through their brains. Not random noise, not the chaotic firing of neurons dying in sequence. This was structured, coherent. The gamma waves appeared specifically in what neuroscientists call the posterior cortical hot zone, the junction of the temporal, parietal, and occipital lobes at the back of the brain. Why does that location matter? Because this exact region has been identified in hundreds of previous studies as the neural correlate of conscious experience. It is the area that activates during dreaming, during visual hallucinations, during altered states of awareness. It is, as far as neuroscience can determine, where the experience of consciousness physically resides in your brain. Your dying brain did not merely stay active. It produced signatures of heightened consciousness in the precise region where consciousness lives. The gamma activity in these dying patients exceeded what is typically observed in healthy, fully awake individuals performing demanding cognitive tasks. If you have ever lost someone, if you have sat beside a hospital bed watching someone you love slip away and wondered whether they were still in there, whether they could still hear you, whether their mind had already gone dark, this data suggests they may have been experiencing more in those final moments than you were standing beside them. Borjigin's 2023 results confirmed what her team had first observed in 2013 in animal studies, also published in PNAS. In that earlier study, rats experiencing cardiac arrest showed a massive increase in coherent gamma oscillations, featuring cross-frequency coupling between gamma and theta waves that exceeded levels observed during normal waking consciousness. The coherence of the signal was remarkable. The dying brain was not degrading, it was organizing. If this is connecting ideas you have thought about, if you want to understand what this surge actually does with your stored thoughts and memories, subscribe now. The next section reveals what physicists believe is happening to the information content of your mind during this final burst. And it changes the entire picture. Historians still argue whether this gamma surge represents genuine conscious experience or merely the reflexive firing of neurons losing their oxygen supply. Borjigin herself cautions that correlation is not proof. They cannot interview the dead. But the specificity of the activation, its restriction to consciousness-associated brain regions, its structured coherence, its cross-frequency coupling, makes a purely mechanical explanation increasingly difficult to sustain. Something deliberate appears to be happening. Your brain, in its final seconds, appears to be doing something with your thoughts, not erasing them, processing them. What almost nobody discusses, what gets buried beneath the headlines about life flashing before your eyes, is what information theory predicts should happen to your neural patterns at the moment of brain death. Every thought you have ever had exists as a specific pattern of electrochemical activity across your neural networks. Your unfinished thoughts, those persistent gamma frequency loops maintained by your prefrontal cortex, are patterns too. Information patterns. And information, in physics, follows rules. The no-hiding theorem, proved in 2007 by Samuel Braunstein and Arun Kumar Pati at the University of York, states that quantum information cannot be destroyed. If it disappears from one system, it must appear in another. This was experimentally confirmed in 2011 at the Indian Institute of Science in Bangalore. The theorem is a direct consequence of the unitarity of quantum mechanics, one of the most fundamental and experimentally verified properties in all of physics. Now consider your dying brain. Your neurons are firing their final gamma surge. Your unfinished thoughts are running through their loops one last time, perhaps faster and more coherently than they ever have before. The electrochemical patterns are converting into electromagnetic radiation as your neurons fire. Every electrical impulse in your brain generates a tiny electromagnetic field. When your heart stops and your neurons begin to die, those fields do not simply vanish. They radiate outward at the speed of light. Think of your brain like a room full of ringing bells. While you are alive, the room is sealed. The vibrations stay contained, bouncing off walls, creating your private inner experience. At death, the walls dissolve. The vibrations are not destroyed. They propagate outward into the open air, weakened, dispersed, but physically real. The information pattern still exists, encoded in electromagnetic radiation spreading through space. Read that again. Your final thoughts do not disappear. They radiate. Physics requires this. Some scientists dispute this interpretation, arguing that the information disperses so rapidly and at such low energy that it becomes functionally irretrievable, which is the same as being destroyed for all practical purposes. Depending on who you ask, this distinction either matters enormously or not at all. But here is the counterargument that quantum physicists find compelling. The no-hiding theorem does not say information is merely hard to find. It says information is physically conserved, as fundamentally as energy is conserved. Your unfinished thought about your grandchild, your unresolved feeling about a choice you made at 35, your half-formed understanding of something beautiful you saw and never fully processed. The information content of each of these, the specific pattern, does not end. It transfers. The 2023 gamma surge data suggests your brain may even know this. The extraordinary coherence and organization of the dying brain's final output looks less like a system failing and more like a system transmitting. As if your brain, in its last moments, is not collapsing into chaos, but instead packaging your unfinished thoughts into their most ordered, most coherent form. The form most suitable for transmission. Terminal lucidity. The documented phenomenon where dementia patients suddenly regain complete mental clarity hours before death supports this interpretation. Patients who have not spoken coherently in years suddenly recognize family members, recall distant memories, and express complete thoughts. Their brains should not be capable of this. Yet it happens so consistently that a 2009 study by Michael Nam and Bruce Grayson at the University of Virginia documented 83 cases across 2 centuries of medical literature. Something in the dying process restores access to information that should have been irretrievably degraded. If your unfinished thoughts persist, if your brain's final act is to gather them, organize them, and transmit them, then the quality of your conscious content matters in ways you may not have considered. Here is what the convergent research from neuroscience, information theory, and quantum physics suggests you should do. First, complete what you can while you can. The Zeigarnik effect tells us your brain maintains active, energy-expensive loops for every unresolved thought. Each incomplete conversation drains your cognitive resources. Each avoided decision keeps neural circuits locked in perpetual rehearsal. Write the letter, make the call, have the conversation. Not because life is short, but because unfinished patterns may be what your brain struggles to organize in its final moments. The cleaner your mental architecture, the more coherent your final transmission may be. Second, practice thought completion daily. Before sleep each night, spend 5 minutes deliberately closing open mental loops. Write down every unfinished thought, the errand, the worry, the unsaid thing. Research from Florida State University by E.J. Masacampo and Roy Baumeister, published in the Journal of Personality and Social Psychology in 2011, demonstrated that simply making a concrete plan for an unfinished task eliminates the Zeigarnik effect. Your brain releases the loop. The plate stops spinning. The energy becomes available for deeper processing. Third, cultivate coherent gamma activity through focused attention. Meditation practitioners show dramatically increased gamma synchrony across brain regions. A 2004 study by Antoine Lutz and Richard Davidson at the University of Wisconsin-Madison measured long-term Buddhist meditators and found gamma oscillations 25 to 30 times stronger than novice controls. If your dying brain's final act is a gamma surge, and if the coherence of that surge determines the integrity of your final conscious output, then training your brain to produce coherent gamma activity while alive may be the most important preparation for death that exists. Fourth, protect your neural infrastructure. Your brain needs your unfinished thoughts to remain accessible, not trapped in degraded circuits. The omega-3 fatty acid DHA supports neuronal membrane integrity, 1,000 milligrams daily. Aerobic exercise for 30 minutes 3 times weekly has been shown in studies from the University of British Columbia to increase hippocampal volume by 2% in adults over 60, directly expanding the hardware available for memory retrieval. Sleep 7 to 8 hours in complete darkness to allow your glymphatic system to clear the metabolic waste that accumulates around active neurons. Fifth, choose your unfinished thoughts carefully. If your brain will gather and transmit its most active patterns in its final moments, then what you choose to leave unresolved matters. Spend your attention on thoughts worth carrying. Deep relationships, genuine questions about reality, creative work that challenges your understanding. These are the patterns your brain will reach for at the end. If even one of these steps made you reconsider how you spend your attention, hit like. It tells the algorithm to show this to more people who need to hear it. Here is what we know. Your brain does not go quietly. 2 separate studies, 2013 and 2023, from the University of Michigan, confirmed that the dying brain produces a surge of gamma oscillations, more coherent and more intense than normal waking consciousness. This surge occurs in the exact brain region associated with conscious experience. And the laws of physics require that the electromagnetic information generated by this surge cannot be destroyed, only transferred. Your unfinished thoughts are not trivia. They are active energy patterns maintained by your brain's most sophisticated neural machinery. They are the cognitive content your mind prioritizes, the problems that mattered enough to keep running, the feelings too important to file away, the ideas too alive to close. And in your brain's final moments, evidence suggests they are not abandoned. They are amplified. Nobody can tell you with certainty what happens to that final transmission, whether the pattern holds together, whether it arrives somewhere, whether some version of you persists in the information that radiates outward from your dying neurons at the speed of light. The science is not there yet. Honesty demands acknowledging this, but the science is sufficient to say this. Your last thoughts are not wasted. They are physically real. They obey conservation laws, and your brain appears to spend its final energy organizing them, not discarding them. I want to hear from you. Drop a comment below. What is the one unfinished thought you would want your brain to transmit? Your unfinished thoughts are not loose ends. They are signals waiting to be sent. Share this with someone who carries unfinished words they never got to say to someone who died. The physics says those words may still be receivable. And if you have not subscribed yet, you should. What is coming next confronts the hardest question in all of this. Who is listening on the other end? The last thing your brain does is not die. It is speak.